now that we understand how to do all the standard algorithms in base 10, let's talk about how to do them in base 6 so that we can really kind of empathize with our students a little bit better and like actually understand like what is actually hard about the about all these algorithms when you're first learning them, right? So we're comfortable with our number system. That's why these problems are very easy for us. So let's get out of our number system, get uncomfortable, and work with something that's a little bit harder. So 24 base 6 plus 13 base 6. What is that? So we could represent this with base 6 blocks. So here I have the number 24 base 6 represented because this is 4 singletons and 2 groups of 6, right? So if I have two sixes and 4 singletons or tens, whatever you want to call them, combined with 1 group of 6 and then 3 singletons. If I want to add these together, what do I get? I can combine those, and I have 3 groups of 6, and then I have 7 singletons. But every time that I see 6 of these singletons, I want to do an exchange. Right? So I'm going to exchange these 6 ones for a group of 6. So I should be expecting the number 41 out of this. Right? So 24 base 6 plus 13 base 6, we should expect to equal 41 base 6, or we know it to be 41 base 6. How is that reflected in the standard algorithm? So 24 base 6 plus 3 base 6. So when I do the 4 plus the 3, 4 plus 3 base 6 is, well, that's, I mean, to us, that's 7, right? But like once you get to 6, then you carry that over. So 3 and 3 makes a 6. So 4 and 3 makes 6 and 1 more. So I carry that 1 over. So it's like really like 11 base 6. Okay. And then I have 2 plus 1 plus 1. Add those all together, and I get 4 base 6. Because that's 2 groups of 6 plus 1 group of 6 plus 1 other group of 6. But yeah, so this is 41 base 6, and that's how this this whole thing is like mirroring this. All right, let's take that a step further. Let's do 135 base 6 plus 322 base 6. Let's do the algorithm first this time and then see how it's reflected with the base 10 blocks. So 5 plus 2 base 6. So add 1 to get to 6, and then another 1 will get you to 11 base 6. You carry that 1 up here. 3 plus 2 plus 1, that makes 6, or 10 base 6, or 10 base 6. And then 1 plus 1 plus 3, that should be 5 base 6. So we should be expecting 501 base 6 here. And if I were to do all the exchanges here, this should be 2 right there. Okay, that's fixed now. So now I have 135 plus 322 base 6. So when I combine the 5 with the 2, I can combine 1 with that. So that's why I'm adding 1 first, and then I add 1 more right here, and then I carry that 1. So I'm doing like an exchange right here. Wasn't supposed to rotate that, but whatever. So I just did that exchange, and then I have the I carry that 1 over. So now I have 1 plus 3 plus 2, and that makes 6, or like 10 base 6. So then I exchange those for one of these. 6 tens makes a 100, or like 100 base 6. And now I have 1 plus 1 plus 3 groups of 6 squared, and that makes 5 groups of 6 squared. And we don't have to do an exchange here. If we had like 6 or 7 of these total, then we would exchange those for a 6 cubed block, but we don't have to here. Okay, so yeah, this is equal to 501 base 6. Let's do subtraction next. If I want to subtract 321 minus 153 base 6, I want to take away 153 base 6 from 321 base 6. Okay, so let's do that. So let's go right to left. Well, I guess we could go. Let's just do it the way that we would normally do it. Let's go right to left. Let's do it in the algorithm first. So I want to take 3 away from the 1 right here. I can't do that, so I have to borrow 1 from this. So I have 11 base 6 over here, and then subtract 3. So counting down, 11, 10, 5. So this should be, wait, is it 5 or 4? So 10, 5, 4, yeah. So this is equal to 4 base 6. Just by counting down 3. Start at 11, go down to 10, then to 5, then to 4. And then I want to take 5 away from this 1, so I'm taking 5 tens away from the 1, 10. I can't do that. I have to take away from this 3 first. I have to borrow. So I'll borrow 1 of the 100 base 6s. Combine that over here. So now I have 11 base 6. I'm taking away 5. I know that 5 plus 2 equals 11 base 6. And so 11 minus 5 would be equal to 2. And then 2 minus 1, I'm just taking away 100 from that, and so I get 124 base 6. And if I were to do this over here, just by doing exchanges, so if I want to exchange this for 6 of these guys, 2, 4, 6. So now I want to take away 3 of them. Oops. So take away 3 of them. So I did that. And then I have 110, and then I want to take away 5 of them. I'm going to do that. I want to do this replacement, exchange that for 6 of these. 2, 4, 6. And now I take away 5 of them. Put that over to the side. Take away 5 of them. Put that up here. And now I just take away 100. Okay, so I've taken away 153. I've taken away 153, and I'm left with 124. Right, left with 100, 2 tens, and then 4 ones. Okay, let's do multiplication next. 23 base 6 times 32 base 6. What is this equal to? So with these problems, it's going to be helpful to know your times tables, which you don't. It might actually be helpful to actually write out a multiplication table for whatever base that you were working with, and have that multiplication table just kind of next to you while you're doing certain things. I won't here. I'm just going to kind of do things because these numbers are sort of small enough that I can kind of just work with them a little bit more easily. So 3 times 2, what is 3 times 2 equal to? So 3 plus 3 base 6 is equal to 10 base 6, because that makes 6. So that's 10 base 6. I'm going to carry that 1 over. And then 2 times 2 is 4, and 4 base 6. And then I add that 1 that I carried over, and so I get 50 base 6. Okay, so 23 times 2 base 6 is 50 base 6. Okay, now let's, so we're done with the 2. Now let's multiply by 30 base 6. 3 times 3 base 6. 3 plus 3 base 6 is 10 base 6. And then plus another 3 is 13 base 6. Let's get rid of that right there. So we have 13 base 6. And then 2 times 3 base 6 is 10 base 6. And then add another 1. That should be 11 base 6. And I'll add that 0 right there. So this should be equal to the sum of 1130 plus 50. Add that. 5 plus 3 is equal to 12. And that makes 2. So 1220 base 6. So 23 base 6 times 32 base 6 is equal to 1,220 base 6. Okay, you could write this out a little bit differently. I'll just do this kind of quickly just because we just did it. So all right, let's do it like sort of one by one. So 3 times 2 is 10 base 6. Okay. Do different colors. 2 times 2, well, really this is like 20 times 2. 2 times 2 is 4. So 20 times 2 is 40. 3 times 3, well, really 3 times 30. 3 times 3 is 9. Well, in base 6, though, it would be 13. So let's put a 0 there because we're multiplying by like 30 base 6. 3 times 30 base 6 is equal to 13, or 130. And then 20 times 30, let's put 2 zeros there because it's 20 times 30. And then put 10 there because 2 times 3 makes a 10 base 6. And then you add all of these up. 0, 1 plus 4 plus 3, that's 12. Carry that over. Oops. Carry that over. This would be 2. Yeah. And so this sort of confirms what we're doing. So whichever one of these two methods you want to go with that. All right, last one. Let's do division. With 243 base 6 divided by 5, how do we do that? So let's see, how many times does 5 go into 243? Okay. So here I'm going to count off by 5s. So counting by 5s in base 6, I go 5. 5 plus 5 would be 14 base 6. Plus another 5 would be 23 base 6. And then 32 base 6. So on. So this is times 2. This is times 3. So 5 goes into 24 base 6 3 times. And then 5 times 3 would be 23. Subtract that. Get 1 left over. Bring this 3 down. How many times does 5 go into 13 base 6? Well, we know that 5 times 2 is 14 base 6. So that's too much. So it's only going to go in 1 time. So 5 times 1 is just 5. 13 minus 5, what is that equal to? That would be equal to 4, because if I were to do 5 plus 4 in base 6, that would be equal to 13. So 243 base 6 divided by 5 is equal to 31 with a remainder of 4.